Let's test ourselves. Alright, so the first question says, a universal statement asserts that a certain property is blank for, and so let's give you a couple seconds to think about this question. And so this is just the definition of a universal statement. So we say a universal statement asserts that a certain property is true. Right? Most all these statements say that something is true for something. And so it's true for all elements. And so later on in our videos, we're going to learn what it means to be an element. So it's true for all elements of a set. And we're going to learn about what defines a set. So it's true for all elements of a set. Alright, so the second problem says a conditional statement asserts that if one thing is blank, then something blank. And I'm going to give you like 15 seconds to answer this. Alright, so just like I said up here, all these statements say something is true for something. So a conditional statement asserts that if one thing is true, so you can't have a statement unless it's true or false, right? So it's either going to be true or false. In this case, we're talking about statements that are going to be true for something. A conditional statement asserts that if one thing is true, then said something else also has to be true, right? Then also, so we put then also has to be true. So as we'll say, then something else also has to be true. So I'll put there, just so that makes more sense. And so, what are conditional statements? Conditional statements are going to be like statements like this: if, and then. So if then statement, right? If this is true, then something else has to be true. So this is our definitions, the first two. And so let's take a look at this one right here. It says, given a property that may or may not be true, so it's going to say may or may not be true, an existential statement asserts the blank for which the property is true. And so I'm going to give you some time to think about that. And remember, like I said, all these statements are asking if something is true or not. Alright, so did you figure it out? It says, given a property that may or may not be true, an existential statement asserts that there is. So that was supposed to be H. There is at least one thing for which the property is true. So that's going to be our answer. And so let's take a look at some examples of these three. And so now we just finished our quiz, right? Our test. So I just want you to take note that all three of these are definitions. And I highly recommend that you memorize and know these definitions by heart, because these are fundamental definitions and statements that we use in math and for logic all the time. So highly recommend to memorize them. And so let's take a look at an example for a universal statement. So we can say all positive numbers are greater than 0. And so let me put out an example first, and then I'm going to explain it to you. And then I'm going to explain how the definition is related to that, our example, and our definition. And so let's see. All positive numbers are greater than 0. So let me type it. Are greater than 0. So all positive numbers are greater than 0. Period. And so a universal statement asserts that a certain property is true. And so, like I said, everything, it's going to say something that is true or not true, because that's what a statement says, right? Either a statement is true or is false. So a universal statement asserts that there's a property that is true for all elements of a set. So for all said elements, and so for our elements for this given set are positive numbers. And so we're going to have some kind of set with positive numbers greater than 0. So it's going to look something like this. Greater x number greater than 0. So I hope that clarifies this statement right here. It's going to have an assertion of what the statement is going to be, which is going to be something that says all elements, which is going to be positive numbers, of a given set, which are sets all positive numbers greater than 0. So our elements are going to be elements past 0, which are going to be 1, 2, and 3. So let's look at our next definition. It says a conditional statement asserts that if one thing is true, and then something else also has to be true. And so let's think about that. Let's give this an example. So we have if 18 is divisible by, let's say, 3. So if this is divided by 3, what number does that give us? 6, right? Alright, so just keep that in mind. Then (18) is divisible by, so let's say 6 first here. Let me erase that. Sorry about that. This is 6 first. So that's going to give us 3. If 18 is divisible by 6, that's going to give us 3. Then 18 is divisible by 3. And so it has to follow some kind of logical consistency, right? Let's say I said 18 is divisible by 3 first. And then I say 18 is divisible by 6. That would be a wrong statement, because I would be asserting that the number 3 is greater than 6, which is a false statement. And it wouldn't be clearly stated, but it could be read that way. And so you don't want something to be read wrong, right? It needs to follow some kind of logical consistency. And so that would give us 6. And so this is example, let's define it with our definition. It says conditional statement asserts that if one thing is true, which says our first part is true, 18 is divisible by 6, then some other thing also has to be true, which says 18 is divisible by 3, which gives us the answer of 6. So let's look at our last definition. Remember what our definition says? It says given a property that may or may not be true, an existential statement asserts that there is at least one thing for which the property is true. And so let's take a look at this example. So it says there is a prime number that is even. And we did this one and similar problems in the section of the video, right? The lesson. So this is more just a review. If said not, because these are the 3 most important things foundationally for the next 8 chapters or so. And so it's really important to understand these 3 definitions. So I'm just using some examples to show you why these definitions are so important, because we build a whole paragraphs off of these couple of statements. So prime number that is even. And so what do you think? What do you think about this statement? So there is a prime number that is even, right? And that number will be 2. And this is the only prime number that is even. And so what do we know? It says given a property that may or may not be true. So this is a property. A property is there is a prime number that is even. And it exerts that there's at least one thing for which the property is true. So this is what it's exerting. It's saying that there has to be a prime number that is even. And not necessarily does it have to be true, but in this case it is true. And so that's the basis of an existential statement. An existential statement doesn't have to be true. It just means that you said something, you made a claim, and that claim could be either claim or statement, right? Or proposition. And it doesn't have to be true all the time. A conditional statement could be false too, right? If my if statement is false, then my then statement has to be false. Let's say if I said if 18 is divisible by 36, then 18 is divisible by 37. And clearly you can see the flaw in that logic. If I said all negative numbers are greater than 0, then that would be a false universal statement, right? And so you can see where the truth could be false, but it says asserts that a certain property is true. So it just makes the assumption that something is true. Doesn't mean that it's going to be true. You just make an assertion / assumption / statement / proposition that may or may not be true. So keep that in mind and remember these 3 definitions, and you don't really need to get caught up into random examples of these kind of things. These are examples that we're just using to clarify the definition, right? Because in the long span of this, we're going to really define what these statements are and just see why they're so important as we go along this course. So thank you guys, and I hope you enjoyed this video. I hope it shows you where you're at in the course and where you need to focus at. And for this last video for the chapter 1, the most important thing was just to acknowledge that you know these 3 definitions. If you know these 3 definitions, that was just the basis of the video. You don't even need to remember everything else. And so like I said, if you liked the video, please give it a like. subscribe to the channel. It helped my channel grow, and I would need my channel to grow because just to keep making videos like this. And thank you guys for everything. It helps a lot, and I'm really grateful for everything that you guys done for me. Just watching the videos and seeing it, giving your feedback. Thank you, and can't wait to see you guys next time. Bye.